Hello, Geography 232 students. Welcome to week 11 of our class. So this is our first week on a new subject altogether. We are stepping away from raster analysis for the remainder of the semester, and we'll spend the rest of the semester looking at modeling and Python scripting. So in this week's lecture, we're going to focus on Model Builder, specifically Model Builder in ArcGIS Pro. So we're only going to be addressing it from Arc Pro, but the principles and concepts taught in this lecture are mostly applicable in ArcMap as well. So if you're still using ArcMap, you'll learn a few things here that you can use in that program. It's not exclusive to Arc Pro, but that will be the environment in which we'll be applying these new skills. All right, so this week we do have a reading introducing Model Builder, and the reading itself is it's designed for ArcMap, but as I said, the principles, they're transferable between the two programs. It's only a two-page read, so I'll have that on Canvas for you. This week's lecture, Model Builder Part 1, and as the name would imply, there will be a Part 2 next week as well. We'll get into the details a bit more, and this week's lab is called Make a Geoprocessing Model. Upon completion of this lecture and lab, you should know how to understand the purpose and use of Model Builder, create toolboxes and models, add objects and run a model, connect model components, and create model reports. Outline for this week's lecture: what is Model Builder? So we'll talk a little bit about what is it, what's its purpose, creating toolboxes and models, setting up and running models, and running Model Builder in ArcGIS Pro. So first, what is Model Builder? Well, Model Builder is a visual programming language for building geoprocessing workflows. So we say it's a visual programming language because it's essentially a flowchart. It's designed to look like a flowchart with various inputs, tools, processes, and outputs. So unlike Python or some other programming language, you don't actually have to know how to script. All you need to do is know how to identify and select tools, literally just drag and drop them into an environment, and then connect them together. And there is some logical consistency and some syntax that you need to know to use Model Builder, but far and away, it's much simpler than programming. So geoprocessing models automate and document each step of spatial analysis tasks in data management processes. That's another thing too I want to highlight. Essentially, you are creating a record of each of the processes involved in a task. So if you are designing a geo process, especially one that you want to share with others or will perhaps yourself do another time or use another time, Model Builder is really useful for documenting those steps. It's essentially a record. It's like going into Microsoft Word and typing out, okay, so first step, select layer by attributes. Second step, buffer. Third step, erase. So as you drag and drop these tools and processes into the Model Builder environment, it keeps a record and you can save it. And as I said, you can go back, use it yourself, or you can share it with others. A model is represented as a diagram, as I said, that chains together sequences of processes and geoprocessing tools using the output of one process as the input for the next process. And so you can see the example here, and we'll get into the details of this example in a moment. But you can see that, for example, the vegetation on the left-hand side, the type of vegetation, you're using a select by attributes tool. So the yellow box tells you that's the tool. The blue ovals are the data, and then the green are the outputs. So you are selecting a vegetation type by attribute. You will then have your selected vegetation, that's the output, and then that output feeds into the next, right? So we have two green ovals there, selected vegetation and buffered roads. Those then feed into the erase tool. The output from that then feeds into the intersect tool. So the output of one process is the input for the next. So it's a flow chart like that. So there is a logical consistency from start to finish. So Model Builder in ArcGIS Pro allows you to do the following. You can build a model by adding and connecting data and tools, iteratively process every feature class, raster file, or table in a workspace. Iteratively means essentially over and over and over, right? So the first iteration, the second, the third, the fourth. So if you have multiple feature classes or multiple rasters or files in a workspace, you can set a model to run each one of those. So let's say there's 10 different feature classes. You can go 1, 2, 3, 4, all the way down to 10, which saves you time, obviously. You can visualize your workflow sequence in an easy to understand diagram, as we've talked about. You can run a model step by step up to a selected step or run the entire model. So let's say there's a certain point you're trying to hammer out the details for. You can just run that selected portion, or you can run the entire model in its entirety. And finally, you can make your model into a geoprocessing tool for sharing with others or accessing at a later date, or you can use the inputs for the model to create a Python script, in which case you could customize it if you know Python, which we're going to learn a little bit about in a few weeks, or you can share it with maybe a classmate or someone else who is more well-versed in Python, and you can build upon that geoprocessing tool that you essentially used. You built the foundation for that in ModelBuilder, and then you can customize it with Python. So there are a handful of things you can do with ModelBuilder in ArcGIS Pro. So in short, what is ModelBuilder? Models can be used to create custom tools unique to your application. The tools can shorten repetitive tasks, those iterations, and tools can be shared with other users. So you can create a tool that others can use, or you yourself can use over and over again. So the building process takes the longest at the beginning, but you may potentially save yourself time or someone else time in the future. So what ModelBuilder is not, what ModelBuilder is not intended for. So models cannot perform tasks that you could not perform manually yourself. So in order to perform a task with ModelBuilder, you have to be able to actually go through each of those steps outside of ModelBuilder yourself successfully. So since models are constructed from tools, variables, connectors, text labels, and other building blocks, your models are limited to the tools to which you have access. For instance, if your model requires the spatial analyst extension and you do not have access to that extension, you cannot build that model. Okay, so if it requires some sort of extension that you don't have, then you're at a loss. Okay, so just be aware that you can't perform anything with ModelBuilder that you couldn't manually do yourself. Also, models are built for scale, and by that I mean they're meant for essentially scaling up. Now, if there's only one single task that needs to be done, it may make sense just to not build the model at all, right? Just to do the steps individual piecemeal, going into your geoprocessing tools, finding the tool, run it, create the output data, take that output data, plug it into the next tool, and so on and so forth. So if it's only one single task that needs to be accomplished, it may not make sense to build a model. Models are ideal for repetitive tasks and or for sharing methods with others. So that's what I mean by scale. So if there's something that's going to be repeated multiple times in the future, or you have a large amount of data that need to be processed, maybe in a geodatabase or elsewhere, then a model makes sense. But if it's just one single task, maybe not so much. So be mindful of that. All right, so here's an example, and this is the workflow that we saw earlier. And this is identify bird habitats. So this geoprocessing tool is used by a conservation organization to identify potential habitats for an indigenous bird species based on vegetation type, distance from major roads, climate, slope, and elevation. And so if you can pause the video at this point if you want, you can kind of take a look at each one of these different variables, inputs and outputs, but we'll go over them step by step. So the first step is to select by attribute. So the model runs the following tool in sequence. First step, select layer by attributes. And what this does is that selects the correct vegetation type from a vegetation map layer. So our first oval on the upper left is vegetation type. So let's say it has 10 different vegetation types. And the type we're looking for are chaparral. Okay, so that's our type. So we select by attribute. The attribute would be vegetation type is equal to chaparral. Okay, so the selection is made, and then that type of vegetation is then output into a new layer, selected vegetation. The next step is to buffer. All right, so this creates buffer areas within a distance of 1,500 feet around major roads. So the input data would be a major roads layer. The distance variable would be 1,500 feet, run a buffer around it, and then the output data are buffered roads. Next step is the erase tool, and the erase tool relies on two previously exported or two previously created output layers. That would be the selected vegetation of chaparral and the buffered roads, a 1,500-foot buffer around the roads. Okay, so the erase, the tool then erase the buffer areas from the selected vegetation areas. And then finally, the last geoprocessing tool here is intersect. So the intersect, will overlay the output of the erase tool, which would be those areas of selected vegetation within 1,500 feet of a road. So you overlay the output of the erase tool with other map layers, including slope elevation, and climate. This identifies the areas that meet all the criteria, and the output is the final output. There's that last oval on the right-hand side. Okay. So that's how it works. And so the cool thing now, obviously, you could do this. You could run each 4 of these processing tools on your own. You could input the data on your own. But the great thing is that let's say you want to check instead of chaparral, you want to check pine forests, or you want to check palms, or you want to check some other maple, some other sort of vegetation type. You can run this exact same tool and just all you need to do is tweak the type, right? And let's say instead of 1,500 feet, you want to do 2,000 feet. And the next time you want to do 500 feet. So you still have that model. You still have the environment with all the tools set, and all you have to do is tweak the variables slightly. Okay. So that's the great thing about ModelBuilder. All right, next up, creating toolboxes and models. So models must be stored in a user's custom toolbox. Now in ArcGIS Pro, when you create a new project, a toolbox is created with the project itself. So you will always have a custom toolbox. You also have the ability to create new additional toolboxes as well. A custom toolbox can be created in any folder or geodatabase, and the file extension for a toolbox is .tbx, and it can be shared by copying the file. So all the steps, the processes, all those, not the data themselves, but the steps involved in the processes are all kept in the toolbox. But if you are going to share a model with someone, he or she will need to have access to the actual data itself. So be mindful of that. If you want to share that, you have to also include the toolbox. Now, a great thing about ArcGIS Pro is that you can share map projects. And if you essentially zip a project and share it, that will include the geodatabase, which contains the data and the model itself. And so that's the best way to do it, is to share a map package with someone else. Okay. So there are 2 ways to create a model. The quickest way is to click the Model Builder button, which you can see an example of down there at the bottom of the screen. Click on the Analysis tab and then Model Builder button. Another way is to right-click an existing toolbox and select New, then Model. So you can do it that way as well. Be mindful that by default, all models are named model to begin. And so if you plan on making additional models, you should change the name. And you should probably just get in the habit of changing it from model for even for your first one as well, just so that you don't accidentally get confused. And it's just, a generic name. So make sure you update that to something more customizable and recognizable for the future. All right, setting up and running models. So when you are designing your model, you'll notice that the color of the input data rather, the geoprocessing tool, and the output are going to be white, or they're going to be gray. They won't have any color. So what that white tells you is that the model is not in a state that's ready to run yet. Once the input data have been selected, the geoprocessing tool's parameters have been set, and the output location has been chosen, then you will see that the colors fill in. So input data are always blue, a blue oval. A geoprocessing tool is always going to be this kind of yellowish orange rectangle, and the output data will always be a green oval. Okay, so ready to run state means all those colors are filled in. And then there's actually an intermediary step that I don't have in this slide because it happens so fast. While you're running a tool, you'll see the input, the geoprocessing tool, the output blink red. So it'll turn red for a moment, then it will go back to its original color. What that's telling you is that it's processing. Okay, so the input data will blink, and then the geoprocessing tool will blink, and it may stay red for a bit if it's processing for a while, and then it will move on to the green. But generally speaking, it happens so fast you won't really notice. But what you will notice is that once a tool has been run, you'll see this color with a shadow. There's going to be a shadow beneath it, and you can see that in the example. So once the shadow is there, that tells you this model has run and the output data have been created. Okay. So how do we add tools to our model? Well, there are a couple of different ways. The quickest is to drag and drop. So in your geoprocessing pane, once you have actually clicked on this model builder button, or you've created your model, then you can drag and drop your tools from the geoprocessing pane. In this case here, I've got buffer selected, so I just did a search for buffer. There it is, drag and drop. You can also search for tools in this little search window just above the arrow. I don't have it highlighted in the slide, but you'll see a search bar within the geoprocessing or model window, and that will also allow you to search for tools. And drag and drop WYSIWYG, if you've probably heard that term before. If you haven't, it stands for what you see is what you get. That means that essentially when you drag it onto the screen, that's what you get, right? So if you drag in the buffer tool, you drag in your input data, you connect buffer to, we'll say, erase or intersect, what you see is what you get in the model. So it's actually telling you exactly what the steps are and the inputs for each of those steps. So in this case here, drag buffer onto the model, and there it is. And so you're going to see it's white, right? So that means it's clearly not in a state that's ready to run yet. So you'll have to, add in your input data for the buffer. You need something to buffer, right? Points, lines, or polygons. You'll then need to set the parameters for the buffer. What's the buffer distance? Is it going to be 10 feet, 100 feet, 1,000 feet? You'll need to choose a few other things. Is it even going to be feet? Maybe meters, maybe miles, right? So you've got all these different parameters you need to take into account. And then you have to choose an output location for the feature class. Once that's done, it'll then change into its correct colors of orange and green in this case. All right, so on the menu in the Model Builder tab or ribbon, you'll see at least these 3 buttons, and there are several others. We're going to focus on these for now. So there's the Validate button, the Run button, and the Intermediate button. So with Validate, something to be aware of is as you add tools and processes to your model, it'll automatically validate as you go. And by validate, I mean it will check to make sure that your model is valid, meaning that there is an input data set, at least one, the geoprocessing steps and parameters have been set, and that there's an output location for your data. So as you add tools and processes, it automatically validates as you go. So that's one of the benefits of the coloring system. It essentially tells you, all right, this model is valid, it's ready to run. Okay. So there are potentially other times when you might need to manually validate your model, and that's when you are running a model for a second time. You've run it through, you can see the little gray shadow at the bottom, and it's time to rerun it for whatever reason. Or if you've modified the model, if you've changed an input, changed a geoprocessing parameter, changed an output location, any sort of modification, you'll need to revalidate. Next up, we have the Run button. Now you should recognize that as a play button that you've seen all over the world. And so that means it's time to run your model. Just click the button, it'll run the entire thing. And then lastly, we have the Intermediate button. So what is intermediate data? That's data that's only needed to generate the final output. So that will be data that you don't necessarily need to keep. So it doesn't have any sort of long-term benefit for your project, but it is absolutely required to get you from point A to point B or point A to point Z, right? So intermediate data as the name implies, it only has an intermediate purpose. It's designed to be temporary, and then when all is said and done, it can be trashed. So that intermediate button helps you define what's intermediate versus what is not expendable and needs to be preserved for the final output. All right, next up we have this navigation window. Okay, so most of these buttons ought to be familiar, but the auto layout button is something that maybe you haven't seen before. So as your model starts to develop and grow and get big, it can get kind of large and unwieldy. And so there's this auto layout button, which will automatically organize your tools, the inputs and the output, so the ovals and the rectangles. It'll put them in a nice, orderly, logical fashion from start to finish. Even if you've got a bunch of different inputs and outputs, it'll still organize them in a more or less logical way. But just be mindful that sometimes a tool may end up someplace you didn't expect it to go, because it can use these very long leader lines to connect an input to a geoprocessing tool and a geoprocessing tool to an output. So if you've got a lot of different inputs and tools and such, it may get a bit crowded, and so it'll stick one of those ovals or rectangles in some place that you don't expect, but it'll still be connected. It just may not be in a logical location that you're expecting. So that's the auto layout button. The fit to window button is just, as the name implies, it fits to the window. So if you've got a lot of tools, it'll essentially shrink them up so they all fit on screen. Lastly, you've got the zoom in, zoom out, the pan, and then the select elements tools. So it'll allow you to select your tools, your inputs, your outputs, and so on and so forth. All right, running Model Builder in ArcGIS Pro. So first thing you'll want to do is click on that Model Builder button, right? You can also right-click on the toolbox, create a new model, or if a model already exists, you would right-click on that model and click on Edit, and that will bring up the Model Builder environment. As I said before, you will want to either drag and drop, so you'll click on the Tools button to bring up your geoprocessing tools, do a search for those there, then you drag it and drop it in. Remember WYSIWYG, what you see is what you get. You also have an option to search in the search bar there. So those are your tools, and it will, anything that you're looking for, you may not know the exact name, but if you do a search, you're likely to find what you're looking for there. So you do a search there, and that will give you your tools, and you will still want to drag from that drop-down window that comes out, you'll want to drag and drop your tool onto the modeling environment. All right, so that concludes this week's lecture on ModelBuilder. As I said before, there is a reading. This is part one of a two-part lecture. So if you are interested in diving deeper into ModelBuilder, feel free to find part two there on my channel and check it out and learn as much as you can. And finally, for this week's lab, for those that are Cypress College students, you're going to use this week's lab called Make a Geoprocessing Model, and you're going to export a graphic JPEG of the completed model diagram once it's all done, and that's what you'll be uploading to Canvas. All right, so on that note, have a great one. Good luck with everything. Bye-bye.